Hi, Year 11. We're now moving on to Chapter 4 of the Cambridge textbook, and we're going to start looking at translations of graphs that we know. So as long as we know our basic graphs, we're going to be looking at being able to translate or move those graphs left or right or up and down. So we have got in front of us in this little table, shifting or translating right and left to start with. So to shift a graph h units to the right, we're actually going to be replacing x by x minus h. And to shift a graph to the left, we're going to replace x by x plus h. Usually, these are going to appear in brackets. So where that comes from is if I have a graph, for example, x minus 2 all squared, for example, if I wanted to find where that cut the x-axis, I'm going to let y equal 0. And what I've basically got there is an x minus 2 times x minus 2 is equal to 0. Because I've got the squared, I've got it happening twice. If I set each of those brackets to 0, what I would end up with is x minus 2 is 0, x minus 2 is 0. Rearranging, I'd get x is 2, x is 2. So I'd have a double root at x equals 2. So what that means is my graph of x squared has moved to cut the axes at x equals 2. For example, there's my graph of y equals x squared. This graph here, x minus 2 squared, we've worked out it cuts at x equals 2. Okay, it's a double root, so it's going to bounce off at x equals 2. So it's going to look like that. Pop that equation in there. So what we can see is a graph that has x minus 2 is going to move to the right 2 units. So if that was x minus any other number, and we've used h, it would move to the right h units. And that's the reason why it's happening. I think it's better to understand the why than to memorize this. So that's what the first thing's happening in here. So if we're going to shift our graph to the left, we're going to replace the x by x plus h. The same thing would happen as we just had in the graph to the right, but if that was a plus in here, I would find that my roots were both negative and it would shift my graph to the left. So that's why that's happening. If we were shifting or translating our graph up and down, what we'd be doing is we'd be adding an amount or taking an amount off our function that we had. So if we were to shift a graph k units up, we would replace the y by minus k. For example, this might look something like this. If I have y equals x squared plus 2, what I'm actually saying there is I've got y minus 2 is equal to x squared. So looking at what our information says in our OneNote here, we've got it written like this. To shift a graph k units up, replace the y by y minus k. So here's my y minus 2 equals x squared. If I add 2 to both sides, it just looks like that. Y equals x squared plus 2. So I've just written a little note in there, or add plus k to the x side of our function. What that would look like, however, though, we all know what our basic x squared graph looks like. That looks like this. If I'm going to add plus 2 to that, or I'm taking minus 2 from our whole function, that graph is now shifting up 2 units, up to here, like this. If it was x squared minus 2, it's going to shift our graph down to minus 2. In which case, we could actually find where it cuts the x-axis as well, because that's a difference of 2 squares. So it would cut at minus root 2 and positive root 2. So that's information that we've learnt before. So we can apply that information to any function. So on your graph paper in front of you, you've got this grey graph here. We don't know what it looks like. We're going to call it f of x. Okay, it could be any function f of x, and we need to know how to shuffle that graph around. If I was going to try and draw y equals f of x plus 2, we know that when we've got that in the brackets and it's with the x, the plus 2 moves our graph 2 units to the left. And that would become the green graph here. And you can see that where it originally cut the axis here on that original grey graph that you've got, it cut at 3, and that 3's moved 2 units down to cut at 1. When it cut at 0, it's moved 2 units down to cut at -2. So our graph now looks like this green one here. F of x plus 2 is the green graph. If we want to use y equals f of x minus 1, okay, note the minus 1 is with the x here, it's in brackets, we move our graph 1 unit to the right. So if I zoom in there, you can see your original graph there is now moved every point 1 unit along. 3 becomes 4, my 0 becomes 1. We can also find where it cuts the y-axis. Now, we can also have a look at the blue and the yellow graph. In this case, we've got y minus 1 is f of x. So if I write that by adding 1 to both sides, that's the same as saying y is f of x plus 1. When that 1's tacked on to the end of that function, it's moving up. So you can see your original grey graph here has moved up 1 unit at every point. The 0 has become 1. Okay, down here, you can see the -4 has become -3, and that would happen at every point along that graph, so it's uniformly moved up. Y equals f of x minus 1 takes that whole function and shuffles it down 1, and that would be your yellow graph. At every point, it has shuffled down 1 unit. Now, we can apply that information to every single kind of graph that we've looked at so far, and we're going to do that now. So if you go to the top of your booklet, about page 3, we'll work through some of those graphs. Okay, so finding this part of your booklet, we're going to look at the parabola. Now we know y equals x squared is a basic parabola, and we know that if we pop a negative in front of it, the negative flicks it upside down. So we think of the positive x squared as happy, the negative is sad, and that's the basic graphs of those. If we were to now add 1 to the x squared, it would move that graph up by 1. If we added 3 to the end, it would move that graph up by 3. If we took off 2, it would move that graph down 2 units, or down by 2. So that is the form of moving our graph up and down. If we were wanting to translate our graph left and right, that would look like these ones. Okay, and we can draw those. We just drew that one. X minus 2 squared moves our graph 2 units to the right. X plus 3 squared moves our parabola x squared 3 units to the left. And this one's a little bit different, and we had a look at this in class. 2x minus 1 squared, it's going to move our graph because there's a negative. We know it's going to move it to the right, but it's not going to move it to the right by 1. So if you just set that bracket to 0, we've actually got 2 of them, what we're going to end up with is x is a half. It's a double root, so it's going to move our graph 1/2 units to the right. So just be noting what happens when that 2's out the front. Okay, noting also that what we call the points where it cuts our axis, we had a little talk about this, these 3 names are interchangeable. The 0, the root, or the x-intercept are all the same. Be familiar with being able to draw these ones. We looked at those in class today, but we can apply that information also to our cubics. So we know what y equals x cubed looks like. Y equals x cubed, its basic shape looks like this. Okay, there's our y and there's our x. You need to know that one. Y equals minus x cubed, okay, is going to be going the other way. And it's got a different colour there for us. Going to go that way. That's minus x cubed. So what we can see here is if I add 1 to x cubed, it's going to push my orange graph up, and it's going to now cut at 1 instead. Plus 3 would push it up to cut at 3, and minus 2 would push the x cubed down, and it will cut down here at minus 2. We can also look at part 4. So what that is saying is, if you're looking, we're in the brackets, the x is going to x minus 2, so the cubic graph would actually shuffle across to 2 units. So if we zoom in here, what our graph would do would get our usual cubic graph, and instead of cutting at 0, it's going to cut the axes at 2. So it would go through like that. We can also find where that graph would cut the y-axis by letting x equal to 0. If we did that, we'd have, minus 2 cubed, because it would be 0 minus 2, which would be minus 8. So it would cut the y-axis at minus 8, which looks sensible when we look at that graph. X plus 3 cubed, you can probably see the pattern here, is going to shuffle that graph 3 to the left. And this one is going to shuffle it 1/2 units to the right. What we can also do is look at circles and semicircles, but I'm going to go down and have a look at, and we can do square roots, the hyperbola next. Okay, so we need to know what our positive and negative hyperbolas look like. Now let's draw those. Here's our basic y equals 1 over x. That's our positive one. If we want to do the negative one, it just changes the quadrants. There's our negative 1 over x. That has asymptotes at x equals 0 and y equals 0. So that's the y-axis and the x-axis. So when we're shuffling our graphs around when there's asymptotes, we're actually also shuffling those asymptotes around as well. And that's something to be very careful of. So what happens here? Y equals 1 over x plus 1. It shuffles that whole positive hyperbola upwards 1. And in doing so, it moves the asymptote from 0 to 1. So I'm popping a dotted line where that asymptote is. You might want to sketch a better one, and we'll look at some in class next lesson. This one here is going to shuffle our 1 over x up 3. So our asymptote, the horizontal one, it's not the x-axis anymore. It's going to be the line that goes through 3. And it's going to be the line y equals 3 is our asymptote. Okay. This one will push the graph down 2, so y equals minus 2 is our asymptote. Our vertical asymptote, which is the y-axis, doesn't change as we haven't moved it left and right. However, if we look at 4, that will change our asymptotes as well. So y equals 1 over x plus 2. That's changed the graph y 1 over x to 1 over x plus 2. It's shuffled the graph 2 units to the left. Remember, positive moves it to the left. What that is also doing is changing our asymptote, our vertical asymptote. We can't divide by 0, so x plus 2 can't equal 0, so x can't equal minus 2. So that's going to be an asymptote for us, and I'm going to draw that over to the right here for you. So here's the graph, y equals 1 over x. And we would like to move that graph and change it into 1 over x plus 2. That's moving the graph 2 units to the left. So we are now going to have this vertical asymptote. Oops, I've just slid over that way. Let's try and fix that up again. There we go. This vertical asymptote that was here has been shuffled over 2 units. Okay, so we just said that we can't have a division of 0. So if x was minus 2 on the bottom, I'd have minus 2 plus 2, which would be 0. So that can't happen. So we've moved that asymptote there. So our graph will now follow that asymptote along, and it will look like this. Same graph, it's just slid over. And so that will happen with each of those that have an asymptote. They will slide. Oops, sorry, I'm having trouble with the zooming. The same with the next one. Plus 3 will move the asymptote over. Minus 1 will make the asymptote 1. So you might want to have a practice at drawing those 3. The same will happen for our exponentials. If we think of what our exponentials look like, a positive 1. I might quickly draw those for you in there. A positive 1 is going to go through there at 0 and 1. And a negative 1 is going to go through there at 0 and 1. If we are adding 1 to the end, it's pushing that graph upwards, pushing that graph up 3, taking that graph down 2 units. They're nice and easy. We've got to note the number 4 here, okay, the x is being replaced by a minus 2. That's pushing our exponential 2 units to the right, okay, because the positive units, the negative units move it to the right. X plus 3 in the power, okay, x is in the power, so it's going to be an exponential, but it's going 3 units. Positive means we move it left. Negative means we move it right. So we can have a go at drawing some of those and maybe popping yourself into Desmos if you're not sure. So basically any basic graph that we're drawn, we can use those rules to have a look at. We're going to have a look at circles in our next video briefly, and we'll have a look at the square root function then as well. But go through here, have a go at filling in the blanks here, have a think about the asymptotes, and if you need to, use Desmos to draw those.